Hello and welcome to your fourth recording for this week on Unit 3, Lesson 2. Just a reminder that I will be out doing makeup OGT testing Monday and Tuesday this week, so you should be watching this recording on Tuesday to be on pace with where we are. Tomorrow, Wednesday, we will be resuming our live classes, so we should have our class at 9:15 Wednesday morning. We are going to pick up right where we left off, so if we take a look at our learning targets, in the first two recordings we looked at identifying and finding the measures of arcs, and then in the last recording and this one we are working on these two learning targets here, using inscribed angles to solve problems and using angles on and inside circles to solve problems. So let's take a look at our next theorem. When we talked about angles on and inside circles, we talked about inscribed angles. Another type of angle we call is on a circle is any angle where the vertex is on the edge of the circle. The only difference between this and the last theorem is now it's formed, instead of by two chords, we have a tangent and either a chord or a secant here forming this angle. But our chord tangent angle theorem says the measure of an angle formed by a chord or secant and a tangent that intersect on a circle at point B here, the measure of that is half the measure of the intercepted arc from B to A. So our angle measure is half the measure of the arc that it intercepts. So let's use this theorem, the chord tangent angle theorem, over the next few problems so that we can practice this idea. So here we want to find the measure of angle EFH. Notice that EF is our tangent, FH is our chord. And so this measure here, the measure of angle EFH, is actually equal to 1/2 the measure of the intercepted arc, which if you look at your circle, it's actually the arc from F to H. So we call this arc FH. And so I know that arc FH is 130 degrees. So if I take half of that, that will give me the measure of angle EFH. So half of 130, or 130 divided by 2, tells us that angle measures 65 degrees. Let's try another practice problem. So this time, instead of finding the angle on the circle, I want to find the measure of the intercepted arc. So arc GF, if you start at G, go around the circle to point F, that is the arc we want to find. And if we notice, the angle that opens up to that arc is actually angle FG, and I need another point here, we'll just say A, because that vertex G is directly on the circle. So the measure of angle FGA is equal to half the measure of the green intercepted arc FGF. Well, now there's a problem here. I don't know the measure of this angle, or it's not given to me. But what I do know is I do know that this angle here measures 122. And the pink plus the red angle, they form a linear pair, right? Here's the common vertex. And this is the common ray. Any angles that share a common vertex and a common ray, they form a linear pair, so they add up to 180 degrees. So if I wanted to, I could actually find this measure here by taking 180 and subtracting off 122. And that would give me a measure of 58 degrees. So that is this angle here. And so now I have 58 degrees is equal to 1/2 the measure of arc GF. And so to get this arc by itself, I need to multiply by the reciprocal of 1/2. So I'm going to multiply by 2/1 on both sides. And so 58 times 2, or times 2 over 1, gives us 116. And that these cancel, so 116 is the measure of arc G to F. And so that's this green arc out here. All right, let's look at another practice problem. So here's another practice problem using the chord tangent angle theorem. Here, I want to find the measure of angle BAD. So that's this angle in red right here, formed by our secant and tangent. And we know that that angle measure, according to the chord tangent angle theorem, is half of the intercepted arc from B to A. And so the measure of angle BAD is equal to 1/2 the intercepted arc from B to A. And I know arc BA measures 124, so I multiply that by 1/2. And I get 62 degrees. All right, let's try one a little trickier, but using the same theorems. All right, so here we are given a triangle inscribed in a circle. We want to find the measure of A, B, and C. So A being the yellow angle, B being the green angle, and C being, we'll say, this blue angle. Now the first thing to notice is that we have a straight line here. It's actually a line tangent to our circle at point A, and we have 3 angles making up this straight angle. We have this 50-degree angle here, we have this 45-degree angle over here, and then we have our yellow angle. So I could actually say that 50 degrees plus A plus 45 degrees must add up to 180, and this is just a straight angle, right? Any straight line or straight angle measures 180 degrees. So I can combine like terms here, 50 and 45, that gives us 95, plus A equals 180, and then I can take away 95 from both sides. And that tells me that A, or the measure of, we'll say angle A, is equal to 85 degrees. So I'll just put in an 85 right here. All right, the next part I wanna look at to continue our solving. I'm gonna use a different color here. We're gonna next find if I want to find B, so if I want to find this angle right here, I know that the intercepted arc for B, that angle has to equal half of, let me use pink here, B has to be half of this purple or pink intercepted arc. So if I could find that measure here, that's going to help me to find angle B. Now to find the measure of this purple angle, I want to note that that I can look at this angle right here, angle EAC, because that has a vertex on the angle. It's formed by a tangent and a secant. And I can use the chord tangent angle theorem here to find the measure of this purple arc. So I can say that, let me draw a line here, I can say that the measure of see if I can write, the measure of angle EAC is equal to 1/2 the measure of arc AC. And that's still the chord tangent angle theorem. So I know that this angle here is 45 degrees, and that is equal to 1/2 the measure of arc AC. If I multiply both sides by 2/1, that will help me solve. And that tells me that the measure of arc AC is equal to 90. So this purple angle here is 90 degrees, or this purple arc here is 90 degrees. Well, knowing that, then B is just half of that. So I can come over here, let me erase this over here. An eraser would work. And come over here and I can say that B, or the measure of B, is equal to 1/2 the measure of the purple arc from A to C. And I just determined that arc was 90 degrees. So 1/2 of 90 gives me the measure of angle B. And so B is equal to 45 degrees. And then you guys might be able to guess what I want to use to find the measure of C over here. I can just use the triangle sum theorem, right? All three angles of a triangle add up to 180. So the triangle sum theorem says that B plus A plus C has to equal 180. So I can actually just take 180 and subtract off 85 and 45. 180 minus 85 minus 45 is going to equal C. And if I do that, 180 minus 85 minus 45 gives me that C is equal to 50 degrees. So combining many of the theorems that we have learned this week, I've been able to figure out the three missing angles inside of a triangle that is inscribed inside of a circle. Okay, let's do one more using this theorem. So here I want to find the measure of A, and this is actually a major arc. If you think back, major arcs are named with 3 letters. So this actually refers to the part of the circle, the part of the arc of the circle from A to E all the way to B. And so the measure of angle DAB is the angle that sits on the circle. So the measure of angle DAB is actually equal to 1/2 the measure of this entire arc right here, AE to B, using the chord tangent angle theorem. And so they tell us that this angle measures 133 degrees. So that is equal to 1/2 the arc measure that we're looking for. And again, remember when solving this, I have to multiply by the reciprocal of 1/2. So that's by 2 over 1 and by 2 over 1. So 133 times 2, or times 2 over 1, gives us that our arc measures 266 degrees. And that's going to be out here. All right. So we're going to wrap this one up from here. In the next video, I'm going to talk a little bit about one more theorem that is called the intersecting chords theorem.